Hey guys, welcome to DevOps School. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps School certification level courses which will help you to emerge skills for a wide range of entry level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
So now what I'm going to do is I am going to help you to install Docker. So how do we install Docker? So I have created a documentation for you. So this is a way tutorials doc. So this is the URL which we can follow. I will also follow the same thing. So I'm going to create one instance CentOS 7. You see here, one CPU, 2 GB RAM. Next, one machine, storage, 30 GB, and this I'll name it Docker, security group, default, review, and launch. Rajesh Mumbai, here it is. So now this instance is ready, and I am going to set up here. The username is CentOS. Keys I am having it. In fact, I'll give you that keys during the lab time. So first I'm going to install it. So let's log in first using the ppk file. And here it is a ppk file. Click open. So username is CentOS. Keys I have already given it. Colors, appearances. Guys, it is visual to everyone.
Yeah.
Okay.
Yes.
Now, guys, important thing is I'm going to install this, but I have a one statement to make. So installation need sudo, you know that, or root, but at the same time Docker also needs sudo or root. Okay. So Docker commands need root access or sudo, or a user need to be in a group called Docker. So if you are applying any of this criteria, then you will be able to access that Docker command. So for an all in all, I'll do this Docker sudo -s. That's all. Okay. So now I'm going to install this Docker. Okay. So for that, I will follow this instruction which I have shared with you. This is for the removing. Okay. So don't follow any instruction blindly. And here I'm installing this. Community edition. C, I'm installing C. Okay. And finally, installation done. Can I check the version of it? And finally, we have to enable it and then start the Docker. Starting the Docker, and then finally, see, info means the Docker is running. Okay, everything is good. Okay, so should read this information, very friendly and useful information. Okay, okay, very good. So guys, Docker installation is done. Did you find any difficulties in Docker installation? Anyone?
No, we are good.
Okay. Now next thing is Docker architecture. Okay. So Docker architecture is important. So in a Docker architecture, we have human. Okay. Human interact with Docker client. Docker client interact with Docker daemon. Docker daemon. Now Docker daemon interact with containerd. Containerd interact with kernel and release all the resources. Okay. Now client. When a client interact with the daemon, they interact with REST API. Okay. So that way, remember the client, it can be in a one machine because of the REST. This can be in a different machines also. So now, which is a client? Let's do that. So which client? See here. Sorry, which Docker? This is the client. Okay. Now where is your Docker daemon? Which ps-ef Docker, and you see this is a Docker daemon. Okay. Which container? So containerd is running there also, and you see type containerd. Okay. Now the question is, what is a containerd? So guys, what has happened earlier? Docker were using LXC to access the container. LXC is another project. Okay. LXC is another project. LXC. It's another project. See here, Linux containers. So earlier Docker were using this one for accessing the kernel, but later point of the time they all migrated to containerd. So now containerd is the standard, industry standard. Look at this here. What it says. Containerd is an industry standard for accessing the kernel for the container management. See here. Industry standard. That means anyone who wants to develop a container interface, they need to use containerd. Why? Because it's a community driven and it's a very powerful product. Okay. So LXC is not anymore. Now it's been used containerd. This is the initiative from the ScmCF. ScmCF is one of the organization which is very powerful organization, community driven and stuff like that. So everyone uses ScmCF. Containerd. So that's the reason. So Docker also using containerd. So this is the architecture of Docker architecture. Is that making sense, guys?
Can you please clear the RESTful API part here?
RESTful means you can it's like through TCP you can connect to other machines. Simple. TCP.
Okay.
Okay. So initially it will run on the socket, local socket. But if you run the Docker daemon on the network, then you can access. So client is here, daemon is here. It can be different machine. These two, it can be in a different machines. Make sense?
Okay.
So guys, what we say, typically when we say these two things together, we call it Docker engine together. What we call it? Docker engine. Okay. So is that clear, guys? Architecture is clear?
Yeah.
Now next thing is, guys, component of Docker. So what are the components of Docker? The first one is Docker engine, which I just installed it. So I don't need to talk about it. You just installed it, Docker client, Docker daemon, and all stuff like that. Everything you have it here. I showed you. These are the commands to check this. These are the commands to check this. Okay, I'm writing these commands here also. Okay, so first one is Docker engine, which is a tool need to be installed. Now next thing is we need Docker image. Yeah, Docker image. So image is what? So guys, image is something is very important. Okay, so image. I've been teaching you here. Each container will get one mount, correct? Right? Mount. Do you remember? Mount. Here we get a one mount, common mount, C drive, D drive, OPT, this, that. Do you remember? Yeah. So the question is, this mount need a file system, then only mounting will happen, right? When you mount something, you know that mount, unmount, mount, unmount, you know that. So mount needs some file system, right? Then only they will mount. So right now, first let's understand the word of mount. So understand that. So this is the file system. Now what are the kind of file system we have nowadays? So one of the file system which you have a boot file system. Boot file system. Example, kernel. This is a boot file system. Then on top of the boot file system, we have a root file system. Example, let me show you image. Refer the image. Let me show you here. I just type root file system. Image. Have you seen this somewhere?
Linux file system.
Yeah.
This is called root file system. What we call it? Root file system. You want to see my root file system? See, what is the root file system here?
C drive.
C drive, yes. And here programs file, Windows, users. These are the root file system for Windows. These are the root file system for Linux. So guys, boot file system, you cannot see it. Boot file system, you cannot see it because the kernel is a kernel, it's hidden, it's loaded in the RAM. Okay, but root file system you can experience every day. You can experience every day. Okay, see here. Look at this image. Boot FS kernel. On top of that, I'll talk about it. This is a one image actually. I'll come back. Look at this image probably. This is good. See here. Look at this. This image is very nice. Look at this. Boot file system has a kernel. On top of that base image. I'll talk about it. Okay. So like this. And then root file system. So root file system, what you can see, operating system file system. Don't I said operating system file system. It's not a kernel. On top of that, what you see, you see user file system. Now, what is a user file system? Let me show you. Go to my user home. Only I can see this, not you. If you are a normal user, you cannot see. This is my user file system. I have a desktop, my downloads, this, that. These are my file system. For me, on my desktop, I have so many. This is my file system. So this is a user file system. Are you
So
getting, guys?
this Rajesh, this file system is so when you say this is user file system, or I'll call it as a user profile, right? The one which you just showed us.
The user profile, you can call it this one, this arrow which I am creating all the time. This is the user, isolated
No,
user. But
the example which you,
it is
the
get to
example which you just,
it
the
is get,
example which you just, sorry, go
huh?
ahead.
Yeah, go ahead.
The example which you gave of your profile, your window explorer, right? That is a profile, right? That is not a file system, correct?
What you see here, it's a profile. Do you think it's a
Yes.
profile?
Yeah, this is a profile, right?
What
Because
is the
user file
what is the
system is
profile?
something which file system is something which is a logical binding from is logical binding to a physical disk space,
So
right?
what do you
So
have?
it's
What binding? What binding?
so C drive is a file
No,
system,
no,
E
no.
drive is a file system.
No, no, no. That's wrong definition. File system means combination of files and directories for serving one purpose. Your Git repository is also file system. I told you in the Git session also. File system. This is a user file system. Here your directories and file serving what? This user. Okay,
Mm-hmm.
I'll put it in this way. I'll put it in this way. Let's say you come to my laptop and I create account. I create 5 accounts. So do each account get the desktop or not? Tell me.
Yep, actually, I'm from a Unix background, so the way I understand is
Okay,
these are stable
forget
files.
about the Unix and Linux. I'm talking about the Linux and concept, and Unix concept is the same. There is no mismatch. In Linux
Mm-hmm.
also, if you talk about here, because based upon the last experience, many people are not comfortable too much with Linux. So I'm trying to correlate with Windows also. This is your
Mm-hmm.
file system. This is your file system. There's
So
nothing
if
you
you
have.
say LSFS there,
LS,
FS
PLK, LSFS or LSBLK you are talking about.
or list FS, maybe whatever it is.
List fs, there is no command as such actually. lsblk is a command. This is a mount. Okay,
Mm-hmm.
so
Okay.
understand the concept of file system first. Okay, so I was talking about if you create a 5 user account in one operating system, so would you get a desktop each account or not?
Yeah, we get a desktop.
You get desktop, you get download, you get a games, you get a favorite, you get a documents, you get everything. The question is from where it is coming. Everyone gets everything, same thing and everything. The question is from where it is coming. So there is a one image is hidden in the operating system. At a Microsoft or Linux, people have that, and that image they mount it. That's what I'm telling you. They mount it to the each user. They mount it to the each user. Look at this image here again. Mount it to the each user. MNT here I'm saying, right? So what is happening here? Understand that here each user get mounted some file system, but the question is which file system we need to discuss. Here you are getting mounted, you as of now, you are getting mounted user file system. You are getting mounted user file system. That means when you log in, you see desktop. Okay, so file system has a different definition. Understand that file system is a group of files and directories for certain purpose. Okay.
Rajesh, I have one more doubt. Like for file system, we also say like NTFS and FAT. Like the
Huh.
how those are
No,
used?
so again, guys, those are driver. You are not in, don't get confused actually. Those are file system driver such as NTFS,
FAT.
NTFS, FAT, overlay, overlay 2, ops. Those are the driver, guys. Device, mapper. These are the driver. Let me show you here. Wait a second. See here. Docker info. You want to know what is my driver? Sudo hyphen s docker info. See here. Where is that? See here, storage driver. So these are the driver which defined how these file system should be stored. These are the software. Make sense?
Yeah. Okay.
Okay. So now these are the file system driver. For example, now that in a Git we have a SHA-256 sort of it, which organizing the file system. Okay. So anyways, not confuse you the out of the track. So guys, understand the definition of file system. So file system means boot file system, which you can see in this image. Okay, it's a Linux one. So here you have a boot file system, which most of the time is a kernel, C groups, capability, which I've been telling you since morning. Now then we have a root file system. I showed you one image also. This is a root file system. Starting from the root, whatever you see, it's a root file system. Then we have a user file system. Then guys, this is the user file system which I was showing you here. Right now in my Linux machine, if I want to see user file system, I have nothing. Why? Because it's a server edition. If you go for the desktop edition, you see that so many things. Desktop edition means designed for human. Server edition designed for the application. So lightweight. And one more thing, you have a plus. Here I'm doing plus. Application file system. What is the application file system? Let's go and show you. C drive tools. Guys, in this we have so many applications. So many applications. SonarQube is there, Maven is there, Java is there. So I want to know this application file system. So here it is. Look at this. This is the application file system. You want to see the tree structure? Look at this Maven tree structure. This is the application file system. See, start from the bin, boot, config, logging. These are the things. So guys, did you understand the concept of file system? Now, guys,
So this is the collection of files based upon who uses them.
correct. Yes, depends on the different. In fact, you know one thing, Git is a file system versioning tool. Git is not a source code versioning tool. It's a file system versioning tool. So you just go and read the internal of Git. You will love those topics. Okay. So now back to the topics here. Did you understand first this point or not? Everyone?
Yeah.
Yes, Rajesh.
Now my question was, what is a Docker image? That was a question. So guys, if you have understood this well, then let me tell you, Docker image is a combination of root file system, user file system, and application file system. Yes, they do not have boot file system. That means they do not have kernel. Again I repeat, these containers will not have kernel. This file system will have only root file system. Yes. See, the only difference is, understand that here. Very simple concept. This user, which is controlled by operating system, is having shared root file system. They all can access whole things, all user. But this guy is very lucky guy. This guy can access their own root file system, not a shared one. So here, that is what I'm saying. Docker image is a consist of root file system, user file system, application file system. So in short, Docker image is a group of file system. Yes, group of file system which contain base operating system, root file system, and application file system and user file systems and all stuff like that. So please do not understand. So now if you see this image, now it will create some sense. This is an image, is a right image. Look at this. This is an image which is a very right image. Only look at this part. See here. This is the boot file system. This is a root file system, which is Ubuntu, Fedora, Debian, SUSE, HP, Amazon. So many flavor of Linux, right? Kernel is one. There is only two kernel in the whole world. Understand that. Nix kernel, Linux kernel, and Windows kernel. So here we have a root file system. Ubuntu has a different root file system. Debian has a different root file system. RHEL, CentOS, Fedora, all these has a different little bit of makeover. They have done it for their own automation. We call it Linux flavor. And then this is a one tool application. This is application. So this is a one application. This is one application. This is what I've been teaching you, telling you. Image has a root file system plus user file system plus application file system. Now, did you understand this? Guys?
Yeah.
Okay. So now in short, guys, in a simple way, if I want to tell you, image, whatever you have in image, yeah. So whatever we have an image, it get mounted one copy. Understand that, mounted one copy of it into container users namespace. See here, this is what I've been telling you. This container get mounted one mount, but with what? This image. So whatever we have an image, it get mounted one copy of it into the container user namespace. Simple. That means whatever you have an image, you see inside a container. Simple. Okay, remember it is a group of file system. Please understand that. Again, I explained group of file system. If you want to understand file system is a combination of files and directories for serving one specific need, such as for booting the system, for routing the system, for user profile, and for application profile. Okay, so guys, did you understand this image concept? Everyone?
Rajesh, you told, container will contain base root file system. So like it will also contain like a program files.
Yes, sir. That's correct.
Windows.
Program, yeah. Right.
So okay.
Whatever you can see here, container will have that. See, whatever you can see here, container will have it. Simple. That means if you go inside a container, you will see this one. That is the reason I've been talking about. Look at this here. I've been talking about OPT Apache. OPT Apache is not possible here. But here, because they have their own file system, OPT Apache is possible. Here, OPT Apache is possible. How come? Because each container get one file mounted, one file system mounted, and that which one? Which one? So starting from the root file system. Getting my
Okay,
points?
okay, got it.
So each file, each container will have their own OPT that way. Here also temp, here also OPT, here also temp, here also OPT, here also the Apache, here also Apache. PID also you get it, network you also get it. So everything is a complete isolated environment. So are you getting my points, what I'm trying to say?
Yes, yes,
Can we move on?
yes, yes, yes.
So guys, this is a Docker engine, this is a Docker image. But the question is, from where we get the Docker image? Are we going to create it? Not now. So from where we get it, the Docker image? Because we need an image. So you have to decide, guys, from where you need to get image. So image is a different type of image. Let me tell you one thing. Image is a different type. When you say Ubuntu, it's a base image. Yeah, it's a base image. Aka root file system. But when I say Jenkins, I think we had a Jenkins session, right? We had a Jenkins session.
Yeah, we are.
Yeah. So when I say Jenkins, that means Ubuntu plus JDK plus Jenkins. So that means, and here you have a user also, Jenkins user. This application and Jenkins user file system. So this is when you say image of Jenkins, then we have a Ubuntu also. Understand this? Very simple concept. Ubuntu also plus JDK, because I've been telling you, right? Application file system. You can have a more application file system, many application file system. You see here more. You look at this image here, no? Look at this here. This is a Emacs application. This is Apache applications. Okay. So now, guys, here this is a Jenkins image. But the question is not this, what is image? Because we understood what is image. But the question is from where to get it this image. So then we have to use Docker registry. What is a Docker registry? Is a collection of, understand, the collection of what? Repository. Yes. Registry has a repository. Now repository has image. Yes, repository has image. It's like a GitHub concept. In a GitHub, you have a repository, and repository has one file system. File system of what? Your application file system. Your whatever the application you develop, you commit, right? That's your file system only, multiple files and directories. Okay. So now the question is, which are the registry? So guys, there are the two kind of registry: public registry, private registry. What is a private registry or what is a public registry? So public registry which anyone can access, like a hub.docker.com, like a Google registry. Okay, these are the public registry. But do we have a private registry? Yes, we have a private registry. I think Artifactory, Nexus training we had it, remember? Guys? Yes. So in the Nexus also, do you remember the Nexus training? We had a provision to create a repository for the Docker also. It was for Maven, Docker, Python, IAM, APT, so many kind of repository you can create it. So Nexus is what? It's a registry. What you create? Repository. What kind of repository? Different kind of repository, including Docker image repository. So Nexus also, you can have on AWS ECR. And here you can have Azure repository, Azure registry, repos. Okay, so many things are there, guys. You can do that. But today in our training, we'll use this. So can we go to the hub.docker.com? Hub.docker.com. Okay. And I will log out. And you see here, this is the home page. I would like you to read this one. Can you please read this? See here. Docker Hub is the largest libraries and community for container images. How much? Over 1 lakh. So if you need an image, you should check it out. It's accessible by anyone, everyone, public registry. So now the question is, you got this place where we can find everything. But the question is, what do you want to run? You want to run Jenkins. So you have to download Jenkins image. Type Jenkins. Or if you want to run root file system like Ubuntu, Fedora, CentOS, Debian, this, that, stuff like that, which is a root file system, you can do that. But Jenkins image has this one also, by the way. Let me tell you, this is the base image. So you see here, I search Jenkins app. So I got official image. Look at this here. You can decide which image is good, which image is not good. Look at this here. Number of download, number of stars, official image tag, different information, updated 7 hours ago. You can filter also. Here is certified image, verified publisher image, official image. By category you can filter. By operating system you can filter. By architecture you can filter. ARM64, IBM, this, that. So guys, this is the place where we can get a lot of image. For example, you want Ubuntu alone, only Ubuntu. You want to enjoy Ubuntu operating system. Kind of environment, not operating system. Kind of environment. See here, Ubuntu. Official image. This is again official image. You want to enjoy SonarQube. All applications you get it. I'm typing something, but it's not. SonarQube. SonarQube. I'm searching. SonarQube. You want JDK? See? SonarQube. You want JDK? Java. You want Perl, you want Python, you want this, you want that. Whatever you want, you will get it in 1 second. Yes, true. So you have to download the images from here. So guys, did you understand the concept? That here I am talking about components of Docker. So first thing, you have to install Docker engine, which is important. What Docker engine contains? Daemon and client, which I said. We installed it. Then we need image. But the question is, we don't know the image. Then I got to know, okay, image is nothing but, Docker image is nothing but root file system plus applications, combination of it. And from where we get it? Docker registry. Which registry? hub.docker.com. The question is, which image you will get it? You get it Ubuntu or Jenkins or blah, blah, blah. Lakhs of images are there. You decide what applications you want to run. So guys, are you getting it now? Guys, are you getting it now?
Yes, sir.
Okay. Now next thing is Docker container. Last component is Docker container. So Docker container, I think you know very well. But here I'll give you one different definition. But just I'll change this a little bit. A moment, what happens? See here. A moment you run image. Yes, I said run. Let me make it in capital. It create one user namespace attached with mount from image and plus attached one PID PID namespace and attach with one net namespace, and this is called container. I've been repeating it multiple times. I hope this is clear now. Guys, everyone? Yes. So guys, before moving further, if you have a doubt, please tell me, so I will help you to sort it out. If you have no doubt, then it's worth me proceeding further, because now after that only simple commands are there. So conceptually you have to understand that commands is just like a matter of 5 minutes, trust me on that.
A specific app file system, and basically when we attach the image, it mounts it, and typically any operating system would need a IP address or whatnot. So you have attached a net NS for this, so that you can play with the IP ports, whatnot, sockets, everything. You will have
Wonderful.
that.
Yes.
And because you need a process file system, then you will, that is something called as a PIDNS, which will help you to have a process file system.
Right.
So basically, you are creating a miniature. You're creating a miniature operating system for you inside an operating system.
100% correct. It's like a feeling is like a that, but it's not a kernel, without a kernel. And that is basically lightweight, consume less CPU, less RAM, less storage, and faster. How much time it get to create? 1 second. So now with that, okay, these are the 4 component. 1, Docker engine. 2, Docker image. 3, Docker registry. And 4, Docker container. With that, I am teaching you workflow in Docker. So guys, how it works? So we need to understand that. So after that, last topic, which is life cycle of container. Damn simple. So workflow in the Docker. So guys, MS Paint. What happens? What happens? This is your node, okay? The place where you will run the Docker container. And then here what happens? I'm the human being. So I will write a command to create a container to what? Client. Docker client. So which client? This is what something I said here. Then client will send that instruction to daemon. Okay, daemon, which is here. Daemon will do one check. Daemon will do one check. What check? The image which I am trying to create a container with, do you have in the local registry or not? Yes, local registry. I said here, remember, this is called remote registry, which is located outside. In the Maven also I told you local repository, remote repository. In GitHub also I taught you local repository, remote repository. So you understand that concept. But here I am talking about local registry, not repository, and remote registry, not repository. So here, do you have in the local registry, do you have that image of Jenkins? No. Then Docker will do, go to the hub.docker.com and download it from here to here. The moment that image is available here is the first time activity. If it is available, then no need to go. Then the movement will start here. Then Docker will request, boss, to what? Container D. Boss, I cannot access kernel. You have a capability to access kernel. Can you please create with this image? Can you create one container? So container D will request kernel, and kernel has all the namespaces which I have been repeating since morning. Same thing, all these capabilities, everything they have it. Container D can read it. Container DC, so sure, not a problem. Let me create one container, that means one user space, and let me mount, okay, pmap, and what is that, network, and then this image has a runtime environment mount. This started running Jenkins, so Jenkins started running here because these mounts come with image of Jenkins also, I mean application of Jenkins. So did you understand? This is called Docker workflow. Docker workflow. Guys, did you understand this flow?
Rajesh, once more, please, if you don't mind.
Yeah, no problem. So guys, here understand that. Please look at this Docker architecture. Human request to Docker client. Docker client send the request to Docker daemon. Docker daemon send the request to container D. Container D request send that to kernel. Kernel is the everything here. What is in kernel? Here I said. So now what happening? What is happening? I send the request to client. Client send to the daemon. Daemon has an additional check available. Are you creating container? But do you have an image available? So first you will check in the local registry. If that image is not available, then it will go to the hub.docker.com, and that's a default registry. It will download and keep it in the local, and from the local, it will daemon will request to the container D to create a container with this mount. Image is nothing but a mount, remember. So container will request to the kernel, and kernel allows all this stuff, and this will release that environment, and this will be keep managing it. If you want to modify something, like means if you want to destroy, again daemon will request to the container D. Container D will do send the instruction to kernel, and kernel will do something here. So this is the complete workflow. Guys, did you understand this?
So one thing, Rajesh. So when you are saying that it is mounting the image, so at that point, this J thing that you have written, is it just reserving that much amount of space?
It's just a J means Jenkins, okay? It's an image.
Okay.
It's an image. So image will get mounted here. So whatever you have here, one mount will happen, right? Image will get mounted here, and inside that, what if you go inside that, you whatever you have an image, you see that. So for example, Jenkins, so you'll see Jenkins application. So Jenkins, you see here again, image, understand that image. Image is nothing but Jenkins for that JDK to have Ubuntu. So this Ubuntu is nothing but a root file system. So Jenkins image will have all three things.
Mm-hmm.
Got it?
Okay.
So inside that, if you go, you see OPT, TMP, Jenkins file system, Jenkins user, everything you get it, and it's a complete environment. That means in a simple what I am been telling you, whatever you have an image, it's get mounted one copy of it into the container of user namespace, to the user namespace, and whatever you see, you have an image, you see inside a container. Very simple. Guys, are you getting?
And how will that image interact with the OS again?
Image is not interacting with the OS. Remember, image is just a mere file system. Real interaction is a file system. Image has a no relationship. Okay, I'll put it in this way. Sir, you wanted one external drive to be mounted. So you write a command mount this external drive to this machine. So do you think you are doing something? or that storage is doing something. No, your kernel is doing something. Mounting is happening by kernel. So kernel is
Mm-hmm.
mounting what? External drive. That is also file system, right? So they mounted
Yes.
in your operating system so you can enjoy. So same thing they are doing. Kernel is mounting this file system. Image is nothing but a file system, but contains your applications also. So it mounted, and now you enjoy the feeling of operating system. Probably if I show you the demo, it will be more clear, I guess.
Okay. No, the thing is that that image that I'm having, that could be of any particular my application or anything, right? So how will that application again interact with the?
Anything, yes. Hello, hello.
Yeah, so how will that application interact back with the OS? Because that application also needs support of the OS as a base platform, right?
That's a very good question actually. And actually, these questions I need little bit of more time because that's a part of my discussion. But right now, I want to give you the time, let's say 30 minutes before I explain it. Because that is a very important question and I need to prove it. Because whatever I've been telling you, I need to prove it, right? So I'll prove it only during this life cycle. Okay?
All right.
Yeah. So guys, so I think I tried my best to explain you containers. I could have gone through only this line of statement and directly install the Docker and then directly hit to the lifecycle of container. That was more easier. But actually you won't understand how this containers is getting powered. So for that reason only, I explain you all this thing. Probably some of you might have understood it, some of you might have not understood. If you have not understood, not to worry, read more about the kernel. It will help you because this is a technology which is a current technology and it's going to dominate in the future. So it's better you read early kernel, namespace, C groups, capabilities, process ID, mounts concept, storage driver. These the early you read it, early you get comfortable with. Okay. So please spend some time, more time with this. Again, you will be having recordings. So in future also, if you want to revisit all this concept again, you can go through that. Now the real thing which you exactly need it is life cycle of container. This is the real command which you will be doing day-to-day activities. And that's damn simple, guys. Let me tell you. Not very difficult. Working with the container is just a fun and nothing. Okay. So here, if I would say, forget about the container for some time. And if I say VM, because VM is the technology which you've been using from last 15 years, 15 plus years. So now you tell me, what is the life cycle of virtual machines? What is the life cycle of a virtual machines? What is the life cycle of virtual machine?
Life cycle of virtual machine.
Okay, I think maybe you are getting confused with the question itself. No problem. So see, life cycle when I say start to end, when you say life cycle, whenever you say life cycle, no, means start to end. Okay, understand that everything has a life cycle in this universe. In fact, universe has a life cycle. It created and die. So like that, in a virtual machines also, you create a virtual machines. Okay, after that, what we do? After that, we start the virtual machine. After that, what we can do? We can stop the virtual machine. Again, we can start the virtual machine. Again, we can restart the virtual machine. Very simple, nothing complicated. If it is running, then you can pause the virtual machine. Pause means pausing, not allocating CPU. Unpause, then allocating CPU again, then pause, unpause, and then a pause is running. Then you can kill the virtual machine. There is stopping and kill also. And after that, You remove the virtual machine. So this is a life cycle from start to end. Correct, right? This is what you do right in the virtual machine. You've been working from last so many years. Correct, no? Right, guys?
Okay.
So basically, this is a life cycle of containers also. Yes, this is a life cycle of containers also. You create a container, start the container, stop the container, start the container again if it is stopped, then restart the container, then pause the container, unpause the container, kill the container, remove the container. Now, this I will show you rather than talking. So let's get started. So guys, here I am teaching you some of the commands which you can use it on daily basis. So please look at my screen here. Now I am showing the demo. So here what I am doing right now, first thing I will check how many images I am having. Docker images. Sorry, bad command. Docker images. See, images when I say repository, tag, let me do the full screen, okay? See, repository, tag, image ID, created, size. So how many images you have? None. I don't have any because I told you, right, guys? In registry, remember the registry concept? So I need images. Which images? I need some images. Let's play with the Jenkins because you know Jenkins very well. Okay, Jenkins. Which image? This image. I want it in my local registry. Okay, so how do we get it? You have a command which is called pull, git pull. Remember git pull, push, same thing here also. Docker pull Jenkins. See here, Docker pull Jenkins. I am pulling Jenkins. And you must be seeing that pulling, 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 pulling. What is that? So basically, guys, these are the file system. This remember, these are the file system. In Git also this concept is there, commit ID. In a Docker we have a commit ID also. These are the ID. What ID? We call it SHA ID. Docker is powered also. Docker image is also powered through the SHA algorithm, SHA-256. You can see it here. Git is also powered by the SHA-1 algorithm. Conceptually, it has a lots of similarities. So here, guys, I got the image. Now, can I check that image? Docker images. Oh, cool. I got the image. What is the image tagged with? Latest. What is the image ID? What when it got created last time? And what was the size? 696 MB. It's a pretty huge image, by the way. But when I say image, please, again I'm repeating, when I say image, that means it has a base file system. It has a prerequisite to run Jenkins. Okay, so I got the image. Now what I said inside a container definition, a moment you run image, it create one container with these namespaces, blah, blah, blah. So now here I am not doing run, but I am following the work life cycle. So what to do? Docker PS. Docker PS will tell you running container. Do we have? None. Docker PS -a will tell you running plus created plus exited container. That means A means all. Do we have any? None. So can we create one container? From which image? Jenkins. Simple. I got created Docker PS. No, it's not running, but it got created -a. See here, container ID, name, image from inside the container. This command is set is created 6 seconds ago. And what is the status? Created name of the container, random name you get it. So guys, I got created one container, but I need to start it, right? So here, can I do one thing? Docker PS -a Docker start. Which one? Container ID. And here, PS -a. See, is running 2 seconds up. Container is running. Now, can I do one thing? Can I stop this containers? So I want to stop this container. So here I will stop this container. And here you see I stopped it. So now whenever you stop it, it will be in exit status. Exit means it has run at least one time. Guys, are you getting my points, what I'm trying to say? Hello? Hello.
Can you repeat the last thing? Sorry.
Yeah, so here I am just following the life cycle of container: create, start, stop. So here I did started. First I created a container from image. After that I started it, and then after that I stop it. Make sense, guys?
Makes sense.
Yeah. After that, what I'm going to do? I'm going to start it one more time. So can I do this? So guys, look at it here, my screen. Starting one more time because it stopped. No, so I'm going to start it. Can I check this? Docker ps. See, it's again running. Earlier it was exited. You see, earlier it was exited. Now it's still running. Again running. So now the container is running. Now can I restart it? So before restart it, can I see that? 19 seconds. Look at this. And when I restart it, see here. See, 1 second. So I restarted the container. So yes, you can restart it also, and you can pause this container, guys. So you can pause this container. See here, I'll show you here. Pause, pause, pause the container, and now you see here, it's got pause. You see here, paused. What is a paused means? Paused containers will not get a CPU allocation. How do I check? Docker stats command. See here, I have one container running. CPU is getting? No. Memory is getting? Yes. Network is getting? Something. So CPU allocation will not happen. So can I unpause it? I am unpausing this, and here, see, stats. CPU started getting. So this is unpause it. So I did pause and then unpause. Finally, I will kill. Brutal way to killing. Killing. What is the difference between stop and kill? So kill will kill the parent ID only, and stop will gracefully kill that process. So this both will fetch the same results. Exit. So -a exited. Now guys, finally my requirement for this container is over. So let me delete it, and that is done by rm. So guys, you saw that I told you, if you understand the concept of container well, within a 5 minutes you can do everything. There's a bad command in there. You can do everything, and so fast. Now you see, I clear the entire things. So now can you create a three? So I need a three containers. So create start, create start, create start. You can do that 3 times quickly. So guys, this is the one. These are the commands. I just ran it in front of you. Only these commands, and work life cycle is completed. So what I did, pull the images, created a container, started a container, stopped the container, again started the container, again restarted the container, pause the container, starts, unpause the container, kill the container, remove the container. Guys, did you understand this?
Yep. And how do we keep the image update for these containers?
Now you have to pull it one more time. You have to pull it.
And how would we? So what is the triggering point? So how would we know that we have to pull it again? Like a new image is
So
there.
image has
Talking
a
about, let's say,
image has a versioning. So whenever someone create images, they keep the versions. So like latest means most recent, but older ones 2.6.3 or Alpine, this one. So if you want to get this older version, you have to specify pull Jenkins colon 2.65, something like this. So you can put it like this. Let me do that rather than talking about. Okay, so I want Jenkins image, but which version I want? I want this older version 2.60.3. So let me pull it that image also. So clear docker pull Jenkins, and which is a tagged latest is a default 2.60 and 3 and 3. See, I'm pulling that particular version of the container. And if you see here, Docker images, see, you got the both older, newer. It's up to you which one. By the way, both are having no changes almost. So did you understand this? The image also has a versioning. Version 1, 2, 3, 4. Who decide this versioning? Depends on the releases. Who decide? Those who created and push it. Make sense, guys?
So once we get the image and once we start using the image, this means we have made it. We have put our own application configuration in those images.
Correct.
And once we get a full image, I think we have to redo everything what we did from our application perspective, right?
Yeah, yeah. You have to create images and see. It's a gradual process. Okay, I'll teach you the how to create images also, but that's a post lunch. First, I'm it's like this. I'm teaching you right now how to play with the containers. Then once you are comfortable with it, then I'll teach you how to create images. But for time being, because you ask here, simply let's say Jenkins. So here this is the.
No, actually, sorry, Rakesh. My question was, Rajesh, sorry. My question was, once I have made my container, now I'll use my container, right? So for the container, using my container means I'll put some of my application configuration in the container.
No, sir. You are against the rule of container. Why you keep the application inside a container? Because container, I said very clearly, container has your application. So if you really want to do anything with your in your container, if in a simple way, if you want to see anything in a container, you modify the image, not a container. You should not touch the container.
So let's say you got the Jenkins container right now, and then in the Jenkins you created two accounts for us, and we started working on Jenkins right now.
Right.
So that is my running Jenkins application on that particular container.
Yes.
Now, if I have to refresh this Jenkins image in the latest version, so what happens to my work which I've already done on the Jenkins?
This is good question. Understand this way. I'll put it in a pictorial diagram. This is your image, which is called version 1, and I'll change the color. Sorry, first version 1, and then you had a new changes here, version 2. Okay, so version 2. Now there is a two things. There is a static content and stateful content. Stateless, stateful. Okay, stateful means the content which you care about it. Stateless, the content which you don't care about it. Stateless means your applications, files, which you can get it as many times. Stateful means the data which generated by applications, which is stateful. So now here what is happening, I am talking about more or less, say, understand this flow. When you create a Jenkins container from the V1, okay, now this is generating this V1, then Jenkins is running, this container is running. Now this will generate stateful data. The stateful data need to be stored somewhere in the persistent storage. That I am not talking about right now. I'm just only focusing on how to run application cheaper, faster, and efficient. Right now, how to do the storage, that's a different topic. We have a persistent storage, we have a volumes, we have a mounts, we have a tempf. The Docker has a volumes. If you know AWS, let me tell you, in AWS, I think, have you gone through the AWS training?
Yeah, we did.
Yeah, good. So in AWS, we have a compute, which are the services EC2. So you only EC2 when you use it, when you want to run application. You don't worry about the storage here. You don't worry, because EC2 is a peril. Understand that EC2 is in peril. That means you terminate the EC2 instance, everything you lost it. So where you store the data in EBS. So something similar concept we have. So right now, what I am talking about, how to run application. When you want the persistent storage, then we have a volume technology with the Docker also. Something like a EBS, which if this container is gone, data is still there, and you can mount to some other container of Jenkins. So that's the one perspective. Now, second perspective, which you said, if you create a one container from the v1 image, then what you have to do, there is no upgrade process you have to do. If you got a v2 image, you have to delete and you have to recreate the here. Now, why? How much time it takes? Millisecond. Yes, I repeat, it takes millisecond because you have seen it just now. So now, instead of upgrading and spending a lot of time for the upgrade process, you recreate it and it will be done in a millisecond. Now the question is, what about the data? So data is here, this volume. Now it will be mounted to this container and you'll have the same data. So volume concept is there. Unfortunately, I'll not be talking about, but I'll share the videos of with you that it will help you. Make sense, guys?
Yeah, this helps.
Okay, guys, so any other questions before recapping the whole point? Any other questions, guys? No. So, guys, let's recap the stuff before moving further. So, here I did discuss about what is Docker. And we understand Docker is a container management tool, it's a platform. Two kind of releases are there, out of which I'm teaching you C Community Edition, written in Go language, and Solomon Hykes release has happened in 2004. For what? It's saving a cost, saving a time, improve efficiency. For what? Running application. Where? In the large scale, in a data center, where that's where the wastage is happening too much. Then we wanted to understand what is a container. Then we understand, if you want to understand the container, you have to deep dive into the kernel. And we understood the anatomy of the kernel and how it works and how an applications can run in the kernel, powered by kernel. So we understood, and then we understand, okay, container is nothing but a lightweight, standalone, complete and independent environment for running any application with user namespace powered by one mount NS, PID NS, net NS, and allocation of CPU is done by C groups. Access of that particular container is being managed by capability. There's a spelling mistake, please do not mind. Capabilities. Okay, now we understood that one. Then we understand what is the use cases of the container, why we are learning. So we understood that container is helping us out to saving CPU, RAM, operating system licensing cost and stuff like that. Ultimately, this one. Okay, and for that we understand other things. Do we have other alternatives than Docker? So many. This URL has so many. Now, how to install Docker? We did it. This URL you just need to follow. Again, Docker needs root. We discussed. Then we discussed about the architecture of Docker. Then components of Docker, which includes Docker engine, Docker image, Docker registry, and Docker container. And finally, I told you workflow of the Docker through pictorial diagram and life cycle of containers, which is command line. So guys, please, from here, that all the images got complicated, but you understand this. This is the physical machine. This is a virtual machine. This is a container. Undo is not allowed now anymore in this. This was a bit concept, something we explained, and like that. So guys, did you understand? Now, did you understand now? What is Docker and what is container and how can you work with it?
I have a question.
Yeah, tell me.
Yeah, Ankit here. So my Jenkins image is running now in container. So how do I perform other operations on Jenkins now?
This is a question which is my next topic. Simple, guys. We run the container, that's okay, but how do we use it? How to use a container? That's a question. How to use a container? That's my next topic. So just give me some more time before. So any other questions, guys? Any other question, guys? Okay. So if you have no any other question, the time has.
So I one more question I am having. So these images we can use it for free, or do we have to create some kind of a account for using it?
Sir, these images I said very clearly. The public registry means any images which is published on the public registry you can use free of cost. Now,
Okay.
without any problem. And how much you have? Lakhs of images you have. Lakhs of, I showed you that image, it's gone. So lakhs of
Yeah.
images you have. So that you can use it. But do you store your own product on a public registry? No. For that, what you will use? Nexus. Now, do you know Nexus? I have already taught you in the Nexus. You can create Maven repository,
Yeah.
Docker repository, Yum repository, APT repository. We had a session, half day session on this.
Yeah. Got it. Yeah. Thank you. Okay, got it.
Rajesh, but if we are pulling like SQL Server or Oracle images, they will have their licensing terms, right?
Yes, sir. That is true. Sir, see, understand that. Image has nothing but I've been repeating you this stuff. Image has a file system. See here. So when I say image, like a Jenkins or let's say for the sake of MySQL, okay? Let's talk about the MySQL. So MySQL image will have a one base image. Now I don't know what base image it supports, but here MySQL supports. Okay, I know that, but I'm telling you, it may be any base image. It may be Ubuntu, Fedora, CentOS, Linux, Windows, anything. So base image, let's say here it's a CentOS. Now on the top of the CentOS, they installed the MySQL thing. Now, if you have MySQL and MS SQL, they have a licensing term, no problem. So application has no problem, right? Getting application file system, not problem. When you run this application, then they will tell you you need to apply this license. So license you can apply manually or any other ways also. Correct? Correct, no?
Yeah.
So license is nothing but one entry in the applications. And application is designed in a way when you push the license automatically start working. That's the concept.
Yeah. Got it.
Yeah, guys, last question who's going to ask before next topic? Okay. So I believe there's no questions. So now guys, now time has come to prove it. Let's prove it. Because we've been discussing a hell lot of things, but we have not proven. So let's prove it. Not this. This one. What is container? So after this, let's prove it. So guys, I'm cleaning up everything in this machine. CentOS sudo. Okay, now how many containers I'm having? None. You see, ps-a, none. Now, I would like to show you ps-ef. These are the Linux command, but very daily commands actually. So here you do have a process of Linux Docker. Let's look at this. See here. So there is no process of Docker. So what I'm going to do is I am going to create a container. But you know one thing, I am very lazy kind of guy. And when I'm lazy, then I tend to find out the shortcut. So I can create a container using create, then start. First I'll pull, okay, pull, then create and start. But I'm feeling lazy. So do you have any commands which is the kind of command which will easy my work rather than multiple commands, one command? So guys, there is one magical command which is there, run command. Okay, so run command will do what? Run command will do few things. It will pull if the image is not there in the local registry, plus it will create also, plus it will start also, and plus it will do become, or in a simple way we call it attached to container. Now this become or attached to container is something which you need to understand. So that is done by run command. Okay, so it will pull, you understand well, create it, you understand well, Start, you understand well, but what is a become? So guys, if you understand that, what you are right now, so what I am right now, if I see what I am right now, so I got to know, PS, I am a bash right now. Yes, I am a bash with the sudo permission. So I am a bash right now. So if you run, then you will become something else. But what? Container. Yes, you become a container. So now let's do this. Docker run Jenkins. And remember, Docker run Jenkins will do all these commands in one go. So I run. And see, I am not anymore bash. I was bash before running this command, but I become something else. Now I have lost my console. What do we do now? This. See here, I have to open up a new console. I cannot do anything here right now. I have to open up a new console, CentOS, sudo -s, docker ps. Now what you become? So guys, if you see that command of the container, bintini. So actually you become bintini. You become bintini. This is called become, guys. This is called become. That means you become a container. That means in a container, you were running bintini with some more parameters, which I'll talk about little later. But you become bintini actually. So right now, this console, what I am right now, is a bintini. It's a bintini. You become bintini. With which user? Jenkins user. So I'll complicate the process here little on interval. Okay. So you are become bintini. So this is called become. So guys, so I don't want to become. I don't want to become. So what we'll do? If I do not want to become, I do not attach to the container process. I want to hold my console. Then what we do? Run -d. So here, do not become. When you run -d, you will not become. So can I try this command one more time? So here I am running one more container. This time run Jenkins. And can I run this -d this time? D means detached. See, still I am a bash. I did not become, but still my container is running. So I have overall 2 containers. One container which I run just now, the one other container which is. So guys, which is a handy command? Run -d. So guys, from now onwards, I will not run these commands, though you can use it for the learning purpose, but handy command for me is run -d. So guys, did you understand these 2 differences?
Yep.
Okay. So now I told you, so from now onwards, to prove this, where is that? To prove this, I will use the run command only because I do not want to run multiple commands. So here guys, I will close this container. I exited this. How come it got exited? I'll teach you also. But right now, docker ps -a, docker stop this container, and docker ps-a, I'm removing that container, docker rm, and here that. Oh, sorry, there's a space. So guys, I cleaned everything so fast. Docker is so fast right now. So now I am to prove it. So let's get started. So let me close unnecessarily window because it's annoying me actually. Okay, so now here look at this. First thing I said, Docker is a container, is just a user space namespace. So now if you see that yourself, look at this. What is your PID number? See, this is you. Look at this. Do you want to trace back? This is you. Yes. You are root 9. This is you. You want to trace it yourself? Let's trace it. You have come from nothing. And what is nothing? 0. Let me trace it. Grep. See here. 19194, 191,194 come from the 19175. 19175 PPID. 19175 come from where? 19174. Trace it. I'm tracing you. I am tracing myself. And 191.174 come from where? 191.71. And 191.71 come from where? 1239. 1239. And you see 1239 has come from where? 1. And 1 has come from where? 0. Let me show you here. PS-EF. See, 1 has come from where? 1 has come from where? 0. That means everything is appeared from nothing. That means 0. This is called process mapping, PID namespaces. So guys, you are also, when you say what you are mere of process. So you are a process. You are a process. But isolated process, which, so basically when you attach the user namespaces, it create a wall. It's like an unseen wall. So no one can go inside your wall. That means any normal user cannot go inside that. But if you are a root user, can go inside, can become that one. So it's like this. So now, can you create a container right now? Docker run -d on the same concept. There is one container I'm creating, guys. Here you see Jenkins, and you see here one container got created. You see here it's running. Can I see now ps-ef grep docker table, ps table grep docker? You see here one container, what you are. And if you trace back this one, guys, you will found it, this process ID also coming from 0. Okay, so if you trace back same way I did it, you will find this. Now can I create one more container quickly? One more container, and you see here 2. See here 1, 2. So that means each container itself is a process for the host machine, and then because of it's a process for the host machine, who gives the CPU and RAM, guys, to this process? Who gives the CPU and RAM to this process?
Kernel.
No. Tell me. This process ID, who allocate the CPU and RAM?
The Docker engine.
No.
The container D.
No. See, state is been created by container D. That's agree. But who allocate the CPU and RAM? I said very clearly, sir. Please recall.
CD groups.
Correct, na? C groups allocate CPU, RAM, IO input to the PID. This PID. And where is that C groups? In kernel. You have in Windows C groups, Linux C groups. Please understand that. Now this container, you want to know this container is running with which user? Do you want to know? So let me show you. Docker execute container ID. I need a container ID. So PS Docker execute exec container ID ps-ef. Sorry, bad command. Okay, ef. See here, which user is running with your container? UID Jenkins. So Jenkins getting the permission what is allowed or what is not allowed inside a container using what? Capabilities. Guys, are you understanding or not? Are you getting my points or not?
Yep.
So understand that. So I'm proving the points which I've been explaining you since morning. So here, yes, container is a mere process. Container is a mere process for the host machine, and host machine knows how to manage that process, allocating the CPU and access and everything. But this is a user process. Again, I'm repeating it again and again, at least so many times. This is a user process. Just like this is you. Okay, so this is proven. So container is a user namespace. But the question is, do they get mount or not? Now again, please do not ask me what is a mount, because we spent 1 hour, more than 1 hour on mount. Mount comes from the image. So image of Jenkins. So can we see that? Docker PS Docker execute which container? This container. What you want to see? I want to see mount inside it. So kh command you do that. See here, this is inside a container. This is inside a container. Can I see the another container mount? See, it's matching. Why it's matching? Because both container has come from the same image and both has the same amount, but behavior is different. Let me prove it. So behavior is different. So what I'm doing, docker execute, first ps, docker execute this container inside opt directory. I will create one file. Which file? Touch opt. Opt will be their file system, root file system. Remember each container. So opt, and here create devops1.txt. So what happened? What has happened? I don't know. Guys, help me.
So you don't have access to that capabilities is coming in picture.
Sir, I'm a root. How can you say I don't have access? Tell me the right reason for it. Tell
But
me.
are you the user in the Docker group?
Yeah, I am the user in Docker. No. Right. Use the right keyword. I think you understood, but not using the right terminologies to explain it. Guys, tell me one thing. Container is running with which user?
We have to log in as a Jenkins user.
No. Container is running with which user?
Jenkins.
So no. Not Docker. Where the Docker is? Container. I just showed you, somewhere on top of this PID Jenkins. So container is running with a Jenkins user. Why? Because Jenkins container, a Jenkins application needs Jenkins user. So what I'm doing, I am executing some commands inside this container. Which command? This container, this command, and this container is writing the file in the OPT. So basically this command is running with the Jenkins user. And Jenkins, that is a normal user. Jenkins will not have a permission to this OPT. For example, if you are a non-root like a CentOS, you cannot write the file inside OPT who's owned by sudo user or root user. Making sense or not?
Making sense, yep.
Yes. So now what I need to do, there is one place I can write a file that is called TMP. Root file system has a TMP also. You know that. And it allowed. Can I do one thing? Can I list out? ls tmp. See, devops1.txt. Remember this I did in this container. Can I do the same thing in the another container? See here. Just change the container ID, okay? I'm changing the container ID. And here you see, I created. Can I list out that file? Oh, I should have done it two also. Let me create one more here. I wanted to show you that isolation things. Two. Can I list out? See guys, in the container 1 you have a DevOps 1, and container 2 you have a two files, 1 and 2 both. See here. So now you see that here, how this isolation is taking place. See, think about it. Both container, think about it. Both container has the same amount from the same image. You see everything same. But if you write in one container, that is not shared by the other containers. So who's making these wonderful things happen? Mount NS, mount namespace. Are you getting my points? Are you able to visualize this?
Yes.
Okay, now the third point which I need to prove it. I told you each container, they get their own PID namespace. So guys, you tell me, in the host machine, how many PID you get it? In the host machine, this machine, the one which I am using right now, how many PID you get it? Guys,
One, right?
Only, yeah, you told me. I think someone told me in the morning, one only. See, I have written here, no? Here you told me one, you get it. And every user share the same pid, correct now?
Yep.
But I said containers will get their own pid. So here you have two containers. Look at this here. Now, can I see that Docker execute inside this container? Just again, Docker ps Docker execute this container and this container ps -ef to get to know the pid. See that? Everything in this here, because see, it start with a 0. That means this container also got their own pid. This container also got their own pid. You see that? And own pid. You look at this. Now, you only told me because if you have one PID, two process cannot have a same PID number. But you see here, Bintini has a 1. Bintini has a 1, same PID number. Java has a 6. Java has a 6, and this is the temporary one which I ran just now. So it is proven that each container getting their own PID namespaces, and because of that, they are behaving independently. Did you understand that or not?
Yep. So Rajesh, maybe this is totally out of the course question. So this is very much similar to, or I can not. It simulates to what we have in our RDBMS. That we have a session management in the database, and then we also have a session management in the operating system. And generally, we are able to map a session of a database to a process in the Unix.
Okay.
So is there a way that we can also see that these PIDs of each Docker are actually a separate process
Yes.
on the operating system?
Everything in the host machine, everything inside a container is a process. Again, I'm repeating. Everything in the container is a process in the host machine. Let's prove it. Let's say Bintini. Yeah? So I'm querying the host machine now, not a Docker. See, two Bintini you should be having. See.
So now my question on top of it is, whatever number of processes I run in my container, outside on the operating system, I'll only see these two processes.
Yes.
Okay.
See, and ultimately everything is I'll simplify this scenario because database scenario a little bit for me also is confusing. I'll simplify this. Let's say you and me have logged in to my laptop, and you run the Jenkins, I run the Jenkins. So don't you think so? You will have a process ID. You have a process ID, I have. But actually, what is happening? The container is kind of creating isolation to behave in an isolated format. So you can run multiple port, you can run multiple PID, same PID and same port and same mount. For that only they are using that Docker for it.
Correct.
Okay, so this is also proven, guys. Now the last thing which I have to prove, let me tell you, you only said in one host you'll get a one network, one IP address, two port cannot be duplicated. But now I'll prove it. Each container here you get the own network. Let me show you. Docker ps Docker exec. You can execute also, but inspect one command I'm teaching additional. You can inspect the container and grabbing only the IP address. I don't need to grab everything. Only IP address -IP. So grab -IP and see here. What is IP address? 3. Now can I change the container? And what is the IP address? 4. 2. So here in this case IP address change. So Jenkins, both Jenkins can run on 8080 port without a conflict. You see here 8080 port, 8080 port. Why? Because the port, network is different. You want to act? See, did you understand this? So this way, I've been telling you, you cannot duplicate. You only taught me 80 port, 80 port, 80 port. It cannot be possible. But inside a container is possible. Why? Because they got own a network, own maps, own PID, own networks, own map, own PID. Now it's possible. So now this guy, the guy name is Solomon Hikes. Where is that? This guy made it possible. And now, because of this isolation, this is one of the preferred way to run application in a data center, in your in your laptop, in your computer. How much time it takes to run an application? Second. And you want to run same application to some other desk, it just need that image. So you have the same image, we get a both. So see here what has happened. Many times you must be hearing about, okay, it's running in development but it's not running in the QA, it's running in the QA, it's not running in the production. And you waste so much of time, so much of meetings, so much of emails, so much of communication, many war rooms getting created to match the environment. But guys, here it's not needed, because you have a same image and it will recreate the same thing every time, no matter which Docker engine platform you run it, whether it's in your machine or my machine, I get same behavior. So it's become portable. Are you able to visualize the benefit of containers in Docker? Guys,
And do you get containers which are multi-application support? Let's say I want a container which contains both Jenkins and Git, or Jenkins and Access, something like this.
why not, sir? Why not? You are the user. Can't you run 5 application? So here I've been telling you. Look at this one more time here. Image. Where is that? Sir, here. Look at this. I've been telling you. Not here. See here. I've been telling you, here you run multiple applications. So same way in the image also, you can run JDK, this is one application. Jenkins, another application. You can run 10 more applications, as many applications you wanted.
So basically, only thing is, then you start with your, then you don't go to a specific application image, you go for a base image, something kind of a concept, and then you keep on installing your applications on
Yes,
top of it.
that's true. And that's the same thing which I had at this image. This image, where's that? Not here. Somewhere I had. This one. Look at this here. Same thing. See here. This is a boot. This is a root. This is the image application 1. This is application 2, application 3, application 4. You can keep doing it in the layers. Layer form. Got it, guys? Okay. So any questions? Last questions who's going to ask?
No, only one thing. So yeah, we do have a recording of this, but does your tutorial, what we just explained, is it in text format in your tutorial also?
Yes. You have a slides actually. So many slides. Typically for the training, I don't use slides because that way it become a monotonous, and I cannot because questions are different. Like different people ask different kind of questions. So that way I cannot immediately change the slides and the stuff. But yes, all the slides are available on devopschool.com. All the videos are available on devopschool.com. All the step-by-step tutorial is available on the devopschool.com. Some of the references I have been sharing you, for example, like this, all these things I've been sharing you. So you have to. But end of this session, I will share you one magical link which will have everything. Let me share you now itself. That magical link is Kit Mastered in DevOps Engineering. Guys, this kit, you at the end, at the top I'm writing, this kit will have everything in one place, linked. So here you see, look at this. Let's say you want Docker, right? To search. So see here, at one place, what happened? Just a second, guys. And past tutorials, actually I have told you, I guess, in the last time also, because this is a not a new batch, right?
Yeah,
So
we know about this.
all the tutorial, all the videos, quiz and dump, notes, PDFs, HTML slides, bloggings, commands, shortcut, cheat sheet, sample code. All this thing is linked together. If you are looking for something which you do not get, you have my email address also. Please do email me.
So typically we start as per your help page. We start from the left, right, and then go deeper into it. Right?
What is that? I didn't understand.
Sorry, from that magic page of yours, we'll start.
If you liked our Docker session so far, please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.